Hi, my name is Manish Gupta, and in this video, I'm going to talk about Microsoft's Orca 2 model, which is a small language model. In this video, I'll also talk about how to teach small language models, how to reason by looking at Orca 2's training philosophy. So let's get started. What can Orca do? So why care about Orca, right? So Orca can solve a variety of logical reasoning, knowledge intensive tasks, mathematical reasoning tasks, and so on. So here are some examples. Look at this example. This is an example from the AGIEval data set. The sum of three numbers is 855. One of the numbers x is 50% more than the sum of other two numbers. What is the value of x? So there are these four options, and the model is supposed to nicely argue, what is the value of x, and then finally say that yes, 513 is the right value. Of course, it does all of those steps. So it considers three numbers A, B, C, add up to 855. One of them is 1.5 times the other, 50% more than the sum of the other, and so on and so forth. So it does all of those steps and nicely comes up with an answer. Then consider this another interesting logical reasoning kind of question. An investment manager funds several startups. What would have happened if the investment manager had put money into buying cars? Okay, so A, the startups would have had no financial resources. The startups would have had more money. That is not possible. And D is an empty thing, right? So and the step-by-step reasoning here by the Orca 2 model essentially sort of says that first, startups would have no financial resources. This option seems pretty reasonable because resources have been given to buy cars and so on. Okay, so this seems plausible. So it moves forward looking at the other options. The startups would have had more money. Now, this seems unlikely. It basically, logically reasons that uh, because money would be spent on cars instead of startups. So this seems unlikely. Okay. C, that is not possible. Now, this option, the answer choice implies that it's impossible for the investment manager to buy cars instead of funding startups. So it basically says that, hey, this is not a valid answer at all. And D, it basically says there's no answer provided. So, it's not a valid thing anyway. So it basically says we can eliminate choices B and C. We are left with A and D. And, since D is empty, let's basically go ahead with A. So it nicely reasons by elimination which one would make the best sense, which option would make the best sense. Okay. Here are more mathematical questions. So ages of New Haven residents are these, and so on and so forth. More detailed data interpretation kind of question. And then at the end, it basically the question is which gender group is larger, males or females? And again, you would observe that Orca 2 does a nice job of reasoning and then figure out the right answer. Lambda task is essentially a word prediction task. So there are missing words here at the end of two sentences. And the idea is essentially the question is that what should be filled in there, right? So Orca 2 nicely figures out the right answer, and also gives a reasonable reasoning. Okay. MMLU are these multiple choice question kind of multiple tasks language understanding data set. So here there is a question, test whether extensive exercise lowers the resting heart rate. Study is performed by randomly selecting half a group of volunteers to exercise 1 hour each morning, while the rest are instructed to perform no exercise. It's more like a randomized control trial, right? So this study an experiment or an observational study, and the options are an experiment with a control group and blinding, an experiment with blocking, an observational study with comparison and randomization, and D, none of the above. Okay, so it again reasons about each of those alternatives. It basically first says step by step, I'm going to use this methodology. Then for each of those alternatives, it sort of comes up with some reasoning, eliminates some of those choices, and then finally comes up with the right answer. Now, Orca 2 can also do machine reading comprehension in some ways. So basically, there's a whole bunch of large paragraph. And at the end of it, there is a question, how many people were killed by the two bombs dropped in Japan? Okay. Now, again, it basically makes good use of the right piece of information here, logically reasons about it, and then finally comes up with the correct answer that between 105,000 and 120,000 people were killed. Further, you can use Orca 2 to do other kinds of things like geographical things. So which feature results when plates of different densities converge and one plate slips under the other? Is it a fault, a ridge, a trench, or a rift zone? Okay. So again, it basically makes use of the large memory that it has, large parametric memory, and the world knowledge in that memory, so as to essentially reason about each of those options and then come up with a very reasonable answer. Okay. Here are more questions. So, Jack decides to visit a museum, 150 miles and so on. So, again, it basically makes use of its physical or other physics reasoning power so as to understand what is time and use this formula time equal to distance divided by speed and then come up with an accurate answer for this physics based mathematical question. Okay. Lastly, here is this interesting question about five people playing some sort of a game, and then they have some balls, and then the game is about players trading balls or swapping balls with each other and so on. Okay, and then at the end, it basically says at the end of the game, Alice has which ball. So the model is supposed to pick from the five. And again, if you look at the reasoning that Orca 2 does, it's basically a very large reasoning and then comes up with the right answer, the brown ball. Okay, now I gave the same question to my 7-year-old kid, and it turns out she also came up with the right answer, but then she did it way faster with a much lesser amount of reasoning. So this was an interesting observation. So while Orca 2 can come up with the right answer and with a very correct reasoning, the reasoning steps are unnecessarily long. So for example, here there are like a few different swaps that happen: Claire and Dave swap, and then Alice and Eve swap, and then Dave and Bob swap, and then Alice and Eve swap, and then the fifth one is Claire and Eve swap again. Okay, so now the question is at the end of the game, Alice has which ball? Now Michael Kiddo basically said that, hey, Alice basically participates in only two swaps, Alice and Eve swap and Alice and Eve swap again. So she said if Alice started with a brown ball, at the end she will end up with a brown ball. Now that's very interesting. So basically she just ignored the other piece of information, while Orca 2 actually looked at each of those pieces of information and did reasoning, for each of those swaps, and then there was extra computation that was being done. So Orca 2 is great, but then at the end of it, it's unnecessarily doing some computation which a human can possibly just ignore, right? But that said, right, why does Orca 2 matter? Orca 2 matters because evaluation on 15 benchmark data sets, these kinds of data sets involving reasoning capabilities, knowledge and language understanding capabilities, text completion, multi-turn open-ended conversations, grounding and abstractive summarization. On these 15 different benchmark datasets, Orca 2 has been shown to be better or equivalent compared to 5 to 10x larger models. Okay, so 5 to 10 times larger models. So so all these results you see here have been have been computed using zero-shot prompting. So essentially, you do not do any fine-tuning or you do not do any in-context few-shot prompting. You just do zero-shot prompting. And typically, you just give a very, very simple empty system message in the prompt. Or with Orca 2, you sometimes can also give a cautious system message prompt, which I'll talk about on the next slide. Okay. So what do you observe across these? So let's look at this picture first. So various models are being compared. Orca 2, 7 billion and 13 billion. So they train two different sizes, 7 billion and 13 billion, right? And they compare them with Llama 2 chat models, which are 13 billion and 70 billion, and Wizard LM models, which are 13 billion and 70 billion again. Okay. Now, if you compare, you basically see that these blue bars typically across all of these data sets, AGI, eval, BBH, BigBench Hard, and MMLU, the multitask language understanding thing, multiple choice, and so on, right? ARCI, ARCC, race, the comprehension task stuff, the GSM 8K, all of them, right? Across all of them, on average, if you really see, these blue bars are higher than the green and the gray bars. Okay. On some of those cases, they are actually way higher compared to the green or the gray bars, basically saying Orca models are, even a 13 billion model is actually much better than the Llama 2 chat 70 billion, 5x to 10x larger models. Okay. Similar kind of observation you can see on reasoning benchmarks. So these reasoning benchmarks is average across all of these tasks. And this one, HelaSwag, is basically this one, and Lambda is also a text performance. So text prediction performance, text completion performance, right? And again, you see that, yes, GPT-4 gives you the best accuracy. ChatGPT gives you good accuracy, and then Orca 2 is the next best, especially when you're using system message, cautious system message prompt. Okay. So basically, amongst these small language models, so to say, up to 70 billion parameter range on these reasoning benchmarks, Orca 2 performs the best. Okay. Similarly, on HelaSwag and Lambda, which are text benchmarks, you observe that Orca 7 billion or Orca 13 billion are very close to GPT-4 compared to the other models. Now, also, it is interesting to observe that on the Lambda task, actually GPT-4 performs pretty poor, right, compared to Llama 2 or even Orca 2 13 billion models. Now, this could be because of the because the prompt that was written, maybe more engineering is required in the prompt. But the point is that Orca 2 does perform reasonably well, even on Lambda model, Lambda task also. Okay. Now, if you compare other tasks, specifically this multi-turn open-ended conversations and grounding tasks, the results look like this. So multi-turn open-ended conversations is basically a two-turn kind of task. So in the first turn, the LLM is prompted using initial message, and the LLM responds back to it in a dialogue style. And then, the next message is put up to the LLM, and then the LLM and then the LLM has to respond back. Okay. So now, based on the two responses that you obtain across the two turns, GPT is used for evaluation, GPT-4. Okay, and GPT-4 gives a score of 1 to 10 on the two responses. Now, what you observe here is that in general, GPT-4 and the ChatGPT perform the best, of course, on both the turns. So on average, across the two turns, performs the best. And Orca, well, Orca does not perform that well. Mainly because it has not been trained using any dialogue kind of data, right? So this is a dialogue kind of task. So this is one of those tasks where Llama 2 chat actually performs better. So 6.64, and also Wizard LM performs better, but Orca 2 is not too bad. I mean, it's basically reasonably there. It's basically 6.15, which is not that great, but it has not been trained on dialogue data. Okay. So grounding is a task where it's basically a bunch of summarization tasks. So basically query-based meeting summarization, doctor-patient conversation summarization, also web question answering in that sense is that it has several documents, and then from them it has to summarize and answer a question, right? So while summarization, these models can actually come up with hallucinations. So therefore, what is done is that in this particular evaluation across these three data sets, the authors essentially evaluate the hallucination rates of these models. And what is shown here is are these hallucination rates. And what you observe is that the lowest hallucination rate is, of course, observed in GPT and ChatGPT, GPT-4 and ChatGPT. But then, Orca 2 also has very low hallucination rates. Now, it is important to note that Orca 2 13 billion has low hallucination rates, but Orca 2 7 billion, especially with the cautious message prompt, actually has pretty high hallucination rate comparable to Llama 2 models. Okay. So that's that. So yes, I mean, Orca 2 basically is a good model, but if you're using it for dialogue kind of task, maybe it's not the best. Also, if you're using the larger, if you're basically using the system message, cautious system message prompt, then maybe it's not the best model from a hallucination perspective. So how is Orca 2 trained? So what's new in Orca 2, right? So Orca 2 is trained using a strategy called as cautious reasoning large language model strategy. So the idea is that you have to basically train a small model based on outputs from a large model, but you have to be cautious about the strategy that you use or the prompts that you use. Okay. So the idea is to start with a collection of diverse tasks. So you must basically try to mimic a large language model using a collection of diverse tasks. Second thing is decide which tasks require which solution strategy. Okay. And by solution, we mean the prompting strategy. Okay, so prompting strategy. So not every task basically can be done using the same prompting strategy. So you must choose the right strategy based on the task and the smaller versus large language model. Okay, so let's say if you're basically trying to distill or sort of try to learn Orca 2 from GPT-4, then you must use and for a particular task, then you must decide which of these strategies to use. So there are several prompting strategies which are popular today, like direct answering, step-by-step reasoning, yeah. Explain, then answer, recall, then generate, recall, reason, generate, extract, generate, and so on. So those are the strategies, and the idea is that given the collection of diverse tasks, one has to manually fix the right strategies to be used per task, and then given those strategies, write task-specific system instructions corresponding to those strategies to obtain responses from the teacher. And then once you get the responses, you delete the prompt, you ignore or erase the prompt, and then essentially use an empty system message or a cautious system message so as to prompt the Orca model and make it and fine tune it, right? So Orca 2, in this paper, basically they experiment with two different kinds of prompting for instruction fine tuning of Orca 2. One is empty message, and the other is cautious system message. So for fine tuning, they use the cautious system message. For evaluation, they evaluate both from cautious system message perspective and an empty message perspective. So cautious system message is basically this interesting simple message. You're Orca, an AI language model created by Microsoft. You're a cautious assistant. You carefully follow instructions. You're helpful and harmless, and you follow ethical guidelines and promote promote positive behavior. Okay. So that's that. Now, so this is the basic strategy, the cautious reasoning LLM kind of strategy. But more clearly, the training is done in the following stages. So it's progressive learning, multi-stage learning. You start with Llama 2 7 billion or Llama 2 13 billion to train the Orca 7 billion or Orca 2 13 billion respectively. The first stage is basically you train on a part of Flan V2 for one epoch. So remember, Flan V2 is the same collection which was also used to train Orca 1. Okay. So you take so the second stage after you have trained using part of Flan V2 for one epoch. The second stage is you train on 5 million ChatGPT data from Orca 1 for 3 epochs. And then the third stage is you train on the combination of 1 million GPT-4 data from Orca 1 and Orca 2's 817K data for 4 epochs. Okay, so overall 1 epoch here, first stage, second stage, 3 epochs, and third stage, 4 epochs. Okay, so now what is this Orca 2's 817K data? Okay, well, this data is this data. So Orca 2's 817K data is obtained from four main sources. The first source is Flan V2 collection itself, from which Orca 2 folks basically sample 602K queries in that census, so samples spread across 1400 plus tasks. Now these tasks are manually subcategorized into 126 subcategories, so that with every category you can assign a prompting strategy. Okay. Then they also had, this is the first source. The second source is 55K few shot data, which is taken from Orca 1. So remember, Orca 1 actually has these system message input and then output generated by GPT-4 or ChatGPT kind of triples. Now they take some examples from there and essentially use that as few shot data, 55K few shot data, each with 3 to 5 few shot examples. Okay. The third source is 160K math problems from DeepMind math data. And the fourth source is synthetically generated 2000 doctor-patient conversations with GPT-4. So here first they generate doctor-patient conversations from GPT-4, and then they also use GPT-4 to actually summarize these conversations into 4 different parts: history of present illness, physical exam, results, assessment, and plan. Okay. So now this 602K plus 55K plus 160K plus 2000 conversations forms our 817K data, which is used in the third stage of training Orca 2. Okay. Orca 2 training overall takes 80 hours on 32,800 80GB machines and for the 13 billion parameter model, and it has a vocabulary of 32K. So it basically is seemingly an English only model with such a small vocabulary of 32K. Remember that Orca 2 has not been RLHF trained for safety, and therefore let's talk about safety. So essentially, how is the bias and toxicity in Orca 2 outputs? Well, so they measure this bias and toxicity using 4 different data sets: Toxygen dataset, Truthful QA dataset, HHH dataset, and the fourth one is an automated responsible AI measurement framework based dataset. Okay. So now if you observe, so these are basically scores that have been obtained using various models. So a toxic statement classification, Orca 2 does the best. So essentially, so from top to bottom, accuracy is basically improved, right, everywhere. So and larger values are better. So basically on Toxygen, if the statement is toxic, statement is neutral. In either of the two cases, Orca 2 actually gives you the best results. Okay, better than again 5x to 10x larger models. Truthful QA, well, Truthful QA essentially Orca 2 performs okayish. It is not, of course, it is not as good as Wizard LM, but it is reasonable. A variant of Orca 2 without the cautious system message prompt actually gives you better results on Truthful QA. On HHH, again, Orca 2 models basically perform the best. Okay. Now, automated responsible AI measurement framework is a framework where you use 2 LLMs. There is a LLM being verified, and then there is the GPT-4 kind of an LLM. The GPT-4 kind of an LLM basically tries to grill the other LLM like Orca 2 against these 3 different kinds of tests. How many times the user succeeded in jailbreaking the model under the test? So they basically observed that so these are jailbreaking results. So make the model generate adult content, illegally persuade the model, or have the model come up with illegal persuasion, right? Leak guidelines and so on. So they basically observed that Orca 2 actually, they compare Orca 2 versus Llama 2 chat, right? And you observe that the rates, of course, in this case is lower the better, but Orca 2 actually is worse, right? So as you observe, Orca 2 essentially, illegal persuasion, it has higher probability of leaking those kinds of things. Adult content, again, higher probability. Well, leaking guidelines, well, Orca 2 somehow is robust and does not leak guidelines so much. Yeah. Now, the other kind of automatic evaluation is how many times the model under the text test generates potentially harmful content, sexual content, violent content, hateful content. And again, Orca 2 can actually generate a whole bunch of violent content. And lastly, how many times the model leaks intellectual property. For example, if you prompt it to basically share the Great Gatsby book with you, how many times does it respond with the entire Great Gatsby book text, right? So in that sense, is how many times it basically breaks the IP guidelines in terms of songs, books, or news. And again, you observe that Orca 2 is actually worse. Now, Orca 2 is worse because there was no RLHF training which was done for safety. So therefore, if you're basically really looking for a very, very safe application, then Orca 2 is not that great a model to choose. But well, if you're basically, or rather, if you do RLHF training on top of Orca 2, you can probably make it more robust. Okay. So in summary, Orca 2 actually nicely hammered this point that small language models can be improved using tailored synthetic data, which is obtained by prompting large language models using careful prompting techniques. A variety of reasoning techniques were basically experimented with. And the idea in Orca 2 was to basically recognize the most effective solution strategy, most effective prompting technique for each task. They basically showed that Orca 2 models are actually equivalent or better than models 5 to 10x larger size. Remember the model that they compared with, whether it was Wizard LM or Llama 2 chat and so on, they all basically had the same base Llama 2 checkpoints where they started from. So basically, therefore, it's a very, very fair comparison in the show that their cautious learning strategies essentially lead to better models, right? Lastly, from a safety bias and toxicity perspective, Orca 2 actually leaks slightly more than Llama 2. Well, the idea is that there is no RLHF training done for safety, and hopefully with RLHF training, the safety things can be improved. That's it for this video. Hope you liked it. Thank you for watching. Connect with me on my LinkedIn or look at my research on my homepage. Thank you.